always the sunrise is at 6, sunset 6. The time is regular for us always. In your country you have the longest day or longest night, and the solstice in June and December, but here you don't find the solstice, no seasons and no changes in the time. Okay, we continue now with our countries. You can find the same line in Indonesia. You can build a sandal like this one. You don't have seasons there. In Brazil you can find the same equator. You can go with your GPS to Kenya, and in Kenya the GPS will show you 0, 0. But here in Quito, you have a difference if you compare the point here with the other points on the equator. Do you know which one is the difference here? No idea? The elevation. It is the highest point on the equator. That's the difference here. Okay. Some people come to Ecuador thinking that here you have the 0 meridian and 0 equator. Is it true or not? What is the 0 meridian?
This is so specific.
In the Atlantic Ocean, really. The 0 meridian is in London, Greenwich.
Yes, yeah,
0 and 0. Okay, now we speak about the Coriolis effect. Maybe have you heard about the Coriolis effect?
No.
Okay, the Coriolis effect in physics is an apparent deviation produced by the rotation of a round object. For example, the rotation of this globe produces a Coriolis effect. Let's check this. In the south you can see a rotation, but in the north too. Is it a clockwise or counterclockwise direction?
depends from the angle.
It is called a centrifugal effect. Is it clockwise or counterclockwise direction?
Clockwise, the other side, and anti-clockwise here.
For you,
Yeah.
right?
Yeah.
But for you, clockwise.
Yeah.
I am on the equator. I cannot see any rotation. For that reason, on the equator, we don't have any apparent deviation in the trajectory of the object. For example, close to the tropics, you have the low pressure areas. When the currents collide, when the masses of wind collide, this provoke a whirlpool. A tornado in the south in a clockwise direction, but a tornado in a counterclockwise in the north. What happens on the equator? Here you don't have the Coriolis deviation, no cyclones or storms, and no low pressure areas. We are going to make it easier with a thing over here. Here's another example. In the nature you cannot see a difference in a short distance, and you need to go really far to see a Coriolis effect. On the equator, the slips will fall straight down. Then I will try the same in the south, and you will find a clockwise direction, the opposite in the north. You should remember, it is an example. Do you want to film it maybe?
I am.
I wait, you can prepare your camera.
I'm ready.
Okay, look at the surface, please. Please closer, you can. There's no whirlpool. The same happens with the massive wind on the equator. They don't provoke a whirlpool. Let's go now to the south. This is around the sink. Okay. In the south, for example, in New Zealand, you will find a tornado in a clockwise direction. The winds are coming from left to right. Okay, now. Take a look.
Kannst du das nochmal erklären, dann bitte? Oh, I can see the difference. What's the difference?
No. You put it like so.
Ja, das Wasser läuft doch trotzdem runter.
Ja, natürlich.
We are now here in the
Ist
north.
das jetzt mit oder ohne Frickstoff?
From right to left in a counterclockwise direction. Okay. You should remember with the Coriolis effect you have two deviations, a clockwise deviation in the south, counter in the north, and nothing on the equator.
Yep.
Wait me a second, please. There you can read the word Coriolis. It is the last name of the French mathematician who discovered this. Forces are other. The rotation of a round object produces a force that comes from the poles to the center, to the equator. Thus are in theory cancelled here. For that reason, this will help us to keep the yolk in the middle. For the next example, you need patience, concentration, and a ROE. If you got it, you will win a certificate. You can try this here or behind it. I have the certificate for you. Please, you can try this here or behind. Who's the next?
Celeste, go. Celeste, try. Try the egg. Try the egg.
Put the egg again.
Balance it.
Balance.
I'm videoing you. Go.
I recommend you to stand on the stone. It's more comfortable.
What am I supposed to do?
You need to move it to the other side or something. Try to balance it. Balance the yolk. It's a bit hot.
Oh, both hands?
Let me
okay,
hold.
okay.
I'll have you come.
Okay, thank you.
Go.
You need to rotate a little by little. Find the center of the egg.
You get a certificate if you can balance it.
Oh, this is very hard. It's impossible.
Possible.
No, my hands shake too much.
Maybe try the shorter nail. Maybe easier. That's what he did. You need to rotate it. I think it's. Oh, I'm sorry. I'm so sorry.
Oh, my hands shake too much for this. Anybody else help?
Really?
These are really.
What are you trying to do?
It's like it's easier to do it when you're actually in the equator because the gravitation is all around or something like that. So if it's very easy for him to do it on the line, but if you do it outside the line, it's hard.
Oh, it's hard to pull your
Yeah.
Because it is more notorious on the equator because of the location on the equator. Okay? Maybe any question? Can we continue?